ENCOR Section 14 Summary Challenge, Wireless Principles. Quite a difficult section, even considering that I do have some prior wireless knowledge, still was quite overwhelming. So let's see. Match the radio frequency signal description with its name. Wavelength. Wavelength is the distance between the peaks of the radio wave measured in meters, so it's a size of the cycle pattern. Or you can take peaks, or you can take like volleys or like crossings over the zero, doesn't matter, right? So basically it's what is the distance between the waves. Frequency is how often the signal is seen, typically measured in number of cycles in 1 second. And amplitude is strength of the signal. This is the correct answer. Question 2. Which one of these represents the best SNR? So we have RSSI and we have the noise value. Okay? RSSI is how much energy is received, received signal strength indicator. And in order to calculate SNR, signal to noise ratio, we need to take the value of RSSI and from it subtract the value of noise. So because we are dealing with negative values here, so in the first case we will take minus 25 and we will do minus 10, so it means plus 10, and we get minus 15 dBm of SNR. So minus 15 here, okay, it's quite low. Minus 50 minus 25 will be minus 25 as a result, still quite low as well. Minus 70 dBm minus 95, we will get plus 25 dBm of SNR, which is okay already. So as I remember, everything which goes above 20 dBm of SNR is considered good. And the last one, minus 95 minus 95 will be 0. So the best signal to noise ratio is provided by this item, this option. Minus 70 plus 95 will be 25 dBm, and this should be the correct answer, I hope. To which segment of the radio frequency spectrum do Wi-Fi networks belong? So it's microwave. Microwave part of the spectrum, radio part of the spectrum is towards the left, where the normal radio stations work, AM, FM, things like that. And microwave part of the spectrum is used by Wi-Fi technology. Which 3 types of antenna cause a butterfly effect in radiation patterns? Okay, so Omni is a theoretical antenna which doesn't exist in reality, just a dot which radiates energy in all directions equally. So there is no butterfly effect here, of course. Dipole is just a straight single piece of metal which radiates into all directions equally, making it an omnidirectional antenna, and there is no butterfly effect. Patch. A patch antenna is like it's like a plane which radiates from it, and it creates basically the range of extended bubble, right? So the bubble of radiation just extended as sort of an ellipsoid. And then we have these 2 options, which I hope are correct. Yagi antenna and parabolic dish. They both are directional, but because of the physics, they also radiate into some secondary directions, right, to the sides, and there might be multiple of them. So Yagi and parabolic dish, I hope, are correct answers here. Which three statements correctly describe Wi-Fi antennas? The two main families of antennas are omnidirectional and directional. This is correct. A directional antenna radiates a different amount of energy as an omnidirectional antenna. This is not correct. So both antennas connected to the same transmitter will radiate exactly the same amount of energy. The difference will be in which direction this energy goes, right? Omnidirectional will go equally in all directions, and directional antenna will have a higher gain into a specific direction. The wave of the electromagnetic signal speed travels at the speed of light, which is close to 300,000 kilometers per second. And this is the correct answer. The speed of propagation of electromagnetic signal is close to the speed of light. The rating of the directional antenna in dBi will be higher, or it will be lower for the directional antenna. So it will be higher in terms of dBi because it provides higher gain in a specific direction. And when we look at the rating of an antenna, we look at the primary direction as this antenna is designed for. So that should make definitely the rating higher in dBi for the antenna. In which two environments is it best to use a parabolic dish antenna? A parabolic dish antenna creates the narrowest beam, which is best for just one single receiver. So it will be great for a point-to-point bridge when we have both transmitter and receiver fixed in their position and not moving around, and they can be configured and directed properly towards each other, and this would be the best use of parabolic antenna. And that typically happens over long distances, so I think this is a correct option as well, but just let's check others. Warehouse aisles, long hallways, I think these two options are equal to each other. Warehouse aisles or long hallways, they are different from these two options here first, because in these warehouse aisles or long hallways we will have clients moving around some bit, right? Quite a bit, and that means that it's better to use another directional antenna to cover this. And large meeting rooms is very likely more suitable for an omnidirectional antenna. In which two environments is it best to use a Yagi antenna? Okay, Yagi antenna provides a directional beam. However, it is not as directional as the parabolic dish. So it will be a good option for long hallways. And I guess this will be another description of what the long hallway situation is. We need a narrow beam, but not as much narrow. So other options, when a wide beam is needed, it's probably better to use a patch type of antenna, which creates this bubble, extended bubble of coverage. Large closets or large meeting room, these are probably good for omnidirectional antennas or patch antennas. So I'll keep these two options. Okay, we have yet another question about antennas. In which two environments is it best to use omnidirectional antennas? Omnidirectional, okay. Covering a large area, probably yes, without any particular direction. Point-to-point, definitely no. Conference rooms, probably yes. We have a conference room, we need to cover it fully. We can use directional and omnidirectional antenna. Long hallways would require a directional antenna, and from building to building is likely a point-to-point parabolic dish. So these two options, 1 and 3, look good. Do we have any other questions apart from antennas in this test, I'm wondering? Apparently not. Match the antenna plane with its radiation pattern. Okay, we have E-plane and H-plane. E-plane is the elevation plane, and H-plane is a horizontal plane. Represents the radiation pattern as seen from the side of the antenna. This is the elevation plane. And this one represents the radiation pattern as seen from the top, and this is the horizontal plane.